to point out that the first question has to do with which of these statements is the least biased. And what biased means is that if you have a bias, it means you have sort of a prejudice or a feeling about something that you are not really willing to adjust, not willing to see the big picture, not willing to open your eyes up to other possibilities. So to have a bias is not typically good, especially when we're looking at, doing data, collection, and when we're trying to get good data to be able to make good reasoning, good decisions about that data. We do not want to have a question or a statement that has bias to it. All right. So, for example, if I'm trying to find out, who's going to win the next student council election, if I, try to get good data so that I have a good idea as to, who might win, I need to make sure that I'm getting data that is representative of different people, that I'm talking to different groups, that I'm trying to make that very random, that I'm not just talking to my friends, that I'm not just talking to, the sixth graders or the eighth graders, that I'm talking to everybody in the middle school, or at least a random, survey of people from middle school. And I want to make sure that the question doesn't have bias. So I don't want to say something like, oh, don't you think, Jane Doe would be the best student council president because she's nice to everybody? All right, that question has bias to it. I'm trying to kind of push you towards, saying, yes, of course, Jane Doe would definitely be the best student council president. So if the question has bias to it, then I'm kind of, getting my answers based on a biased question. So that is not good data to work with. So that's the idea of what they're getting at here. They're saying which of these questions would be the least biased. In other words, which of these questions does not have that skew to it. It makes it much more open-ended, like I'm just trying to get your opinion, not like I'm trying to push you towards my thought process. So A, smoking is okay as long as you don't smoke around people who mind, right? Okay, that question has bias. That statement has bias. If I say, don't you think it's true that people who, can smoke as long as they don't smoke around people who mind? I'm pushing you towards my way of thought, my point of view. Again, it really doesn't matter what the point of view is. If I'm pushing you towards a point of view, we'd say that that question has bias. So that is definitely not the least biased. Do you believe people have the right to smoke? Okay, that's much more general question. Do you believe this? Yes or no? All right, just getting the information. I'm not saying, this is my perspective. I'm not pushing you in a subtle way towards my perspective. I'm just saying, do you think people have the right to smoke? Versus now we look at the third option. Since cigarettes are dangerous and have deadly side effects, wouldn't you agree that smoking would ruin people's lives? All right, again, this question gives bias to it. It really doesn't matter whether it's a true statement or a not true statement, whether you believe it or not. What they're getting at with this is clearly this question is pushing you towards my point of view or a point of view. All right, I'm talking about the fact that cigarettes are dangerous, deadly side effects, ruining people's lives. That kind of terminology, those kinds of statements definitely are pushing you towards a specific point of view. So this question has a lot of bias to it. All right. C would definitely not have the least amount of bias. And then D is not bad. Do you agree that smoking is okay? All right. So you might say, well, B doesn't have very much bias. D does not have very much bias. So the question is, which is the least biased? Okay. So again, A is probably, let's put it this way. C is certainly the most biased. All right. A definitely has bias. B and D, we're trying to decide which one's the least. So the answer is B, and the reason it's B is because D does a little bit of pushing you towards a point of view. Do you agree? All right. Do you agree that smoking is okay? Or maybe I'd be saying, do you agree that football is the best sport? Or do you agree that swimming is the best sport? If I say, do you agree that, that's again kind of pushing a little bit of my point of view on you. All right. So the best least biased question here, or least question statement here, I should say, is do you believe that people have the right to smoke? All right, so I'm just trying to get your perspective. Okay, so the answer there would be B. Again, you might say to yourself, well, what does this have to do with math? Well, the idea is if we're going to do data analysis, if we're going to try to take data that we've collected and actually take the time and effort to analyze that data, we want to make sure that the questions that were asked or the statements that were said were good. We want to make sure that the data is representative of that, of good population. Everybody's been given a chance to speak. So if you were the kind of person that was in a field where you were, let's say, helping do data analysis on upcoming elections, or helping do data analysis on, I don't know, different projects that were being looked at for a city or a state or, a country in terms of government and so forth, you'd want to make sure that your questions or your statements don't have bias, and you want to make sure that you're getting representation from everybody. Otherwise, it doesn't pay to do the data analysis because you have, we call it garbage in, garbage out. You have bad data. It doesn't pay to analyze it because you're not going to get anything valuable out of it. So that's what they're getting at with this. For the second one, they want you to write an equation based on this diagram and find the value of x. So in terms of writing an equation, we can see that 1, 2, 3, 4 sections out of 6 make 24. So 4/6 of the x value is 24. So we could write our question that way. 4/6 simplifies to 2/3. So we could say 2/3 of x is 24. Again, where are we seeing 2/3? Well, that's 4/6 simplified. Or you can think of it as, I could divide this into thirds. There's 1/3, there's 2/3, there's 3/3, and 2/3 of the total length of x is 24. Now, in terms of solving that, you could do it a couple different ways. You could divide both sides by 2/3. All right, that would work. Or you could say to yourself, if this is 24, then that means each section here is going to be 24 divided by 4 or 6. So if this is 6 and this is 6 all the way along, all right, then I can figure out my total length that way as well. Either way, we get x equal to 36. Justin thinks an angle measuring 90 degrees is considered both an acute and an obtuse angle because it's a right in the middle, he says. So he thinks it's right in the middle of acute and obtuse, so it's both. Is he correct? Explain why or why not. So of course he's not correct. We don't call a 90-degree angle acute and obtuse. Instead, we call it a right angle. Acute means less than 90. Obtuse means greater than 90 but less than 180. A 90-degree angle is right. It's not a combination of acute and obtuse. You'll also have to calculate the missing angle measurement. The key I want to point out to you about this is you're not going to be using a protractor. You're going to be using what we know about angles. So what we know in this case is that this entire thing, all the way from here to here, is 180 degrees because it makes a straight angle or a straight line. So if A plus 50 equals 180, then we can take 180 minus 50 to find the measure of A, which is 130 degrees. To find the missing angle measurements here, again, they don't want you to guess. They don't want you to measure with a protractor. They want you to calculate it. So what you're looking at here is a couple things. First of all, we know that 32 degrees, this angle right here, is opposite B, all right? And opposite angles are called vertical angles, okay? And they're congruent. So we know that angle B is called a vertical angle. It's vertical to 32 degrees, and so therefore it's congruent. So therefore we know that B is 32 degrees. Then for how I found A, well, we know that angle A forms a right angle, a 180 degree angle, a straight angle, with the 32 degrees. So you can either think of it as these two together make 180. So 180 minus 32 equals A. Or if you prefer, you can think of it as these two angles make 180. Either way, 180 minus 32 gives you the measurement of angle A. So angle A would be 148. So we say that angle A is 148, angle B is 32, And the reasoning is what we talked about. For this one, the perimeter of the square to the left is 84 feet. So what is the length of each side? The key to this is we know what perimeter means, the distance around the outside edge, and we know a square has all congruent sides. So if all the sides are congruent and they add up to 84 feet, then what is the length of each side? Well, that means 4 times the side length has to equal 84. You can divide by 4 and find out that each side length is 21 feet. Then you'll have to solve and check some solutions, okay? So 6 times x minus 6 equals 60. So the first thing you would do, excuse me, my allergies are flared up. The first thing you would do is to add 6 to both sides. And again, our goal here is to get the variable by itself, x by itself. So if we add 6 to both sides, then what we're going to get is 6x equals 66, because the 6x comes down, the plus 6 and minus 6 zero out, the equal sign comes down, and 60 plus 6 is 66. Then we're going to divide both sides by 6 to get x, the value of 1x, or just x. So we get x equal to 11. So that would be the solving. And then the checking, remember, is when you go back to the original equation and you put in the value of x that we have determined it to be, which is 11, and see if the left side equals the right. So we want to know if 6 times 11 minus 6 equals 60. Well, 6 times 11 is 66. 66 minus 6 does equal 60. Since 60 equals 60, we put a check. It checks out. You have to do some additional checking and solving of equations. So for this one, you want to get rid of the plus 16. So you would start by subtracting 16 from both sides. Again, the 13x comes down. The plus 16 and minus 16 zero out. The equal sign comes down. And 42 minus 16 is 26. You divide both sides by 13, because we're going to get 1x, not 13x. So x equals 2. And then put it into the original equation to make sure that it checks, and then show the check. Again, we've got additional ones of those. So I have a number of different examples here so that you can see those. And if you have any questions, you're welcome to ask me about them or email me about them. But again, hopefully that should all be a review based on what we've done previously. Another one you'll have to do for the quiz is to classify the angle and estimate its measure. So in other words, classify means, is it acute? Is it right? Is it obtuse? Is it straight? Well, we can tell that the angle is less than 90 degrees, so we know it's acute. Estimating the measurement, you would probably say to yourself, all right, it is about 60 to 70 degrees. The way we can tell that is that we know that a straight line coming up from this vertex would be about here. Okay, so this would be 90 degrees. So we can tell it's less than 90, but how much less than 90? Well, looks like maybe 60 to 70 degrees. And then you will have to measure it with a protractor. So this is one where you would have to bring out your protractor and measure it. And so you'd line it up. And then check to see what the measurement is, which is actually 65 degrees. Well, I think I should probably move that over slightly, but yeah, hopefully you can see that on there. All right, then again, classifying the angle and estimating the measure, and then finding the actual measure. So I'm going to move this protractor over. You can tell it's bigger than 90, less than 180, so that means it's going to be an obtuse angle. You might estimate it to be about 140 to 155. We'll take the protractor in, check for the actual measurement. Again, we can tell from the estimate it's bigger than 90, so 90, 100, 110, 120, 130, 140. Looks like about 145. Yep, I got 148 degrees. You're allowed to be a couple of degrees off. So I would say based on when it comes out, I probably would have said more like 140, 146, 147, 148, anything in there is fine. Same thing here. Although here you probably could figure it out without having to actually use the protractor, because it just says to estimate, and you can tell from the picture it is a right angle, 90 degrees. Jessie has been training for an upcoming marathon. She's kept track of how many miles she runs every day for the past 2 weeks. Calculate the mean. So remember, the mean is when you add up the values. Notice I put parentheses around them because we need to first get that sum and then divide by 14 because there were 14 values in the list. If you put in your calculator 3 plus 7 plus 9 plus 12 plus all the way up to this and then divide by 14, because this is divided by, remember, if you don't put parentheses around this, it will only take the 24 divided by 14, depending upon your calculator. All right. So a lot of calculators will do order of operations, which means it'll take that last number divided by the 14 and then just add it to the sum of these others, and you'll get a very strange answer. So it's really important that you remember that you need to either put parentheses around these numbers to say, hey, I want that total sum first, then divide by 14, or that you hit equals before you divide by 14. So you should get a mean of 14 miles. Here we've got additional data, and this time though they ask us to find the median. All right, calculate the median. So remember, to find the median, you put them in order from least to greatest. We were fortunate because they have these already, it looks like, in order for us, but if they weren't, we'd have to put them in order. And then you want to work your way to the middle. Median, of course, is the middle value when the numbers are in order from least to greatest. So in this case, it's between 13 and 14 because there's an even number of values, so it'll be between 2 in the middle. And so then what's halfway between 13 and 14? 13.5 miles. The next question again gives us the data, and this time says to find the mode. The mode is the value that occurs the most. So what we're looking for is which value out of these lists occur the most, and that is 13. Don't forget that it is possible to have no mode if no value occurs more than any others, and it is also possible to have more than one mode if, for example, a number occurs twice and so does another number occur twice, and that's the most. So then you'd have 2 modes. Jessie's coach said he should be able to choose any day at random from the last 2 weeks, and she should have run 13 or more miles if she's going to be ready for the marathon. What's the probability that he's going to choose a day from the list? I should say from a list, not from the list, from the last 2 weeks with 13 or more miles. So if you look at, again, that set of data, the set of lists of numbers, the question is, how many of these days did she get 13 or more miles? Well, she got more than 13 or 13 miles or more these days. So that is a total of 10 out of 14. So 10 out of 14 is the same as 5/7 when you simplify it. So that's the understanding there. And then, which measure of central tendency should she report to her coach if she wants to impress him? Remember, measures of central tendency is what's a typical value. So we look at what she found for mean, median, and mode. Okay, her mean was 14, her median was 13.5, and her mode was 13. So the best day, the one where she had the best information, was the mean because her mean was 14. So if she wants to impress him, she should tell him the mean value versus the median. All right. Again, we typically look at mean and median as values of central tendency, typical values. Mode is occasionally looked at, but it's not really a very good central tendency value. So really we're asking ourselves is, which value is higher, the mean in her list or the median in her list? Zach wanted to research how many students would attend a bake sale. Which method listed below is an example of a random sample and why? So again, we want good data. How do we get good data? We make sure we have a random sample. That's one way we do it. So if he asks everybody who walks by during lunch, that's an option. He could ask his friends. He could ask everybody in the culinary club, or he could ask every 8th person on a list of all enrolled students. Hopefully what jumps out to you is that D would be the best way to do it. All right, asking his friends is definitely, asking his friends is definitely not giving us a good representation of everybody. Culinary club, that means like a cooking club. And of course, they're going to have a different point of view perhaps than other people. So it's not nearly random enough. And everybody who walks by is fine, except for the fact that if they're set up like we are, where a middle school and a high school, you're only getting the people in your lunch. So instead, just taking a list of all the enrolled students and just randomly picking every 8th person, this is definitely the most random. Okay, so this is the best way to get the good data. Then Cody measured this angle below and got 70 degrees. Do you think he's correct? Why or why not? So what they want you to realize here is he's not correct. The problem is that we can tell just from looking at this angle that this is bigger than 90 degrees. So if we can tell from looking at it's bigger than 90, 70 is not a good value. And what was he doing wrong? Well, he was looking at the wrong value. He was looking at the top set of numbers instead of the bottom. So just from estimating it, we can tell a better one would have been 110 degrees. True or false? Complementary angles can add up to 180 degrees. Well, complementary, remember, are where they add up to 90. It's a pair of values, pair of angles, measurements that add up to 90. Supplementary add up to 180, okay? So this should be in your workbook for the quiz and test. Complementary angles are a pair of angles that add up to 90. Supplementary angles are a pair of angles that add up to 180. So this statement is false. Remember, the hint that I gave you is that I remember it as C comes before S and 90 comes before 180 in terms of remembering which one's complementary and which one's supplementary. So those are the types of questions that you will see on the quiz.